Okay, welcome. Welcome to the deep dive. Today we're jumping into a really fascinating connection. It's drawn from a stack of sources, and it links something you might, see on a blackboard with something you definitely see on your dinner plate.
That's right. We're looking at how these, seemingly abstract mathematical concepts, maybe ones you're actually tackling in college right now,
Mm.
have incredibly tangible applications, real world stuff.
And this deep dive, pulling directly from our source material,
Hmm.
it zeroes in on the relationship between, well, the mathematical tool of differentiation and critical field of food security.
Food security. Yeah, it might sound like a bit of a leap from, say, calculus class,
Right.
but our sources, they really lay out a clear path. They show how differentiation is absolutely relevant here.
And the specific link, the one revealed in the material, is all about exploring the rate of microbial growth as it connects directly to food spoilage.
Exactly. Preventing food spoilage is just essential for global food security.
Yeah.
And understanding how quickly these microorganisms, bacteria, mold, that sort of thing, how quickly they grow on food is, it's a key factor.
Okay, so this is where the sources point to differentiation coming in. It's like
Mhm.
the main tool for understanding it, how quickly part.
Precisely. Differentiation, at its heart, it's all about measuring the instantaneous rate of change.
Hmm.
So if you have a function describing, let's say, the population of bacteria on some food over time,
Mm,
differentiation lets you figure out exactly how fast that population is growing at any specific moment.
right, so you might be in class, studying derivatives, calculating slopes of tangent lines, and thinking, okay, yeah, math is math. But the sources show how this very concept translates directly to something like figuring out a food's shelf life or designing the right storage conditions.
Yeah, absolutely, because you need to know that rate of growth. What's really crucial here, and the source points this out, isn't just like the total number of microbes eventually, it's the speed at which that number is changing.
Ah, the speed.
Yeah, microbial growth, especially when conditions are good for it, can accelerate really fast, often exponentially. So if you don't understand that accelerating rate, you can't predict or prevent spoilage effectively.
Okay, so it's the speed of the increase, the how fast it's happening right now that the math really helps us nail down.
Exactly that. By modeling the growth and then using differentiation to analyze that rate, food scientists can actually determine critical thresholds. They can say, okay, at this temperature, this kind of microbe on this food reaches a dangerous growth rate after, say, X hours.
Wow.
And that's just invaluable information.
That really is fascinating. So this abstract mathematical concept gives us a truly practical way to measure something vital, something for keeping our food supply safe, reducing waste. It's like a direct line from a math equation to, well, a sell-by date on a milk carton or a refrigeration rule.
It really underscores how these foundational mathematical principles are just, woven into the fabric of so many practical sciences. The ability to quantify and understand rates of change.
Yeah.
It's powerful across many fields.
Absolutely. So just to kind of circle back on what we've pulled from the sources in this deep dive,
Mhm.
the core idea really is using differentiation to measure and importantly understand the rate of microbial growth in food spoilage.
Yeah.
It's a really clear, very practical link between, seemingly abstract math and a very concrete challenge of keeping our food safe.
It's a great example of theory meeting application, isn't it?
It really is. And it kind of leads you with this thought, doesn't it? Think about the world around you. I mean, even in the most ordinary things, like the food you'll probably eat later today,
Hmm.
how many other everyday processes, might be silently governed by these mathematical principles you're learning, just waiting for you maybe to connect the dots.
Yeah, the opportunities for discovery are, they're everywhere, really.
Until next time.